Okay, this is a quick test to check the frequency count library with a Teensy 3.5. This problem was, or issue was reported on the forum here, where it's having trouble with higher than 12 megahertz, and we need to see if this really works. Honestly, as this question points out, I never really tested it with 3.5. We just assume that it works because it has similar hardware. So here's the frequency count library page over here, and we can see that we use pin 13 to get the signal in. So coming over here to the hardware, we have the Teensy card, and I have a couple wires I'll just plug in here and try to get these lined up on the card. Hopefully this all comes through in this video okay. The ground is here, right next to the pin 13 input. There, I hope I've got those hooked up right. That would be embarrassing to have that wrong in this video, wouldn't it? Then I have this cable here that I'll be connecting for the signal input, and we have the oscilloscope here. So here's my scope probe, so we'll be able to actually see these waveforms, and I think we're going to see that my function generator isn't so wonderful. So here's the bench that we're doing this on. Here's the oscilloscope we'll be monitoring the signal with, and here's where all of the rest of the action will be happening in this video, is this function generator here. If I can get the camera stable. This is obviously not a high quality video production, but this is sort of a test run of a recently set up video capture on the oscilloscope, so hopefully I can do these kinds of videos quicker and easier than I have in the past. So let's try first coming over here to Arduino, and we'll upload the code to the Teensy 3.5, and then when we open the serial monitor, well, it's good that we're seeing zeros because we haven't turned anything on yet. So let's turn on a square wave, and let's configure for the amplitude. We want a high level of 3.3 volts, and we want the low level to be 0 volts. And since we're testing high frequencies, let's start at 1 megahertz. Then come over here and turn the output on. Hopefully we'll see it on the oscilloscope. There it is. We can see the measurements. And over in Arduino, we're actually measuring 1 megahertz. So let's try coming back over here to the waveform, and we'll turn up the square wave frequency. Let's turn this up and see if we can. There's 3 megahertz, 4 megahertz. We should see both the oscilloscope and obviously we're getting on the oscilloscope too fine of a display here. Let's change the time base. You can see that this the Siglant function generator leaves a little bit to be desired in the high frequency quality of its waveforms, although that could be this test setup as well. We'll keep turning this up. So we'll go up to 20 megahertz here. Take a look over at Arduino. Seems to be working okay. Are obviously not getting much of a square wave anymore on the scope, but let's keep turning this up. I think that technically the timer that's inside the Teensy that's doing this measurement might be here. We're having trouble triggering. Where are we on a delayed sweep? There, yeah, that's this function generator. Obviously is not able to produce much of a square wave anymore at this frequency, but looks like we're measuring it reasonably well. If we come down, this I believe is as high a frequency as we go. If we could try to enter 31 megahertz, yep, it doesn't like that. It definitely doesn't want to go higher than 30. It will do a higher sine wave frequency though. So let's switch over to sine wave, and let's try going up to 40 megahertz and see what happens. And you can see, I look over at the oscilloscope, and we're still measuring it, but the amplitude of the waveform, it's no longer going down to ground, and it's no longer getting up near 3.3 volts. So when this stops working, it's going to be hard to tell. Did it stop because we weren't crossing the digital threshold? There's 50 megahertz, and it looks like we're still measuring it okay. The scope obviously is able to measure it. let's try changing back to an offset voltage, and then let's go to an amplitude, and let's try seeing if we can increase the voltage a little. So you can see it growing on the scope. This is kind of reaching the limits of what my equipment can do here. But let's try going over to the frequency and try turning it up even higher now. You can see that we're really losing the amplitude. And there, the oscilloscope stopped triggering properly, but if I change the trigger level, we can still... The oscilloscope is, the quality of the waveform is obviously not wonderful. Oops, I just changed some settings on the scope and I'm not sure what I did. There's the waveform though. Let's try coming back down to 50 megahertz real quick. Let's see, we don't want, this oscilloscope has way more features than we want. Okay, let's try seeing if we can get even here. We're obviously not getting any more amplitude, even though we're asking for 6 volts peak to peak. The function generator isn't really able to. Let's try increasing to 60 megahertz, and unbelievably Teensy is still doing okay. Let's see if we can get the oscilloscope to trigger on this again. I might have to increase the amplitude, bring the signal down here. Okay, this oscilloscope is able to do. Let's zoom in like this. Okay, the scope still likes it. I'm pretty amazed that this is working at all at this frequency. Let's keep going. So there's 70 megahertz, and definitely we're not working anymore in Arduino. We're not able to go up to 70. So it looks like maybe around here 65 is as much as we can do. And let's try. And the oscilloscope is thinking it's it's not high accuracy on its frequency counter. It does have a frequency counter feature though, doesn't it? I think it does. Let's not learn how to do that during this video though. One thing I'd like to try here is, can we change in 1 kilohertz increments? Like here's 4 kilohertz increase, and the frequency count library is seeing it pretty well. You can see over in the Arduino window, obviously you can't see this in the scope's measurement, but we can see that the frequency counter in Arduino is detecting these little minute changes in frequency. Let's go down and do only 10 hertz. So if we look over at Arduino, we've got obviously the frequency of this, the accuracy of these two is not perfectly agreeing, but it looks like we're getting variations of down at 10 hertz is about where the noise is. But if we turn this up by just 20 hertz, can we see the effect of that? Obviously the frequency counter the generator did something, but look, we did go up 20 hertz. We went from 718 on the end to 739. It is definitely, if we do, let's do 10 more hertz and see if we can go up from 739, and now we're at 751 to 752. So yeah, it does appear to be detecting these minute changes in frequency up here, even at 65 megahertz. So it looks like the answer to the question on this forum, we come back over here to the Teensy hardware, is this little guy is capable of measuring with the frequency count library. It looks like the limit is around 65 megahertz. That's it. Thanks for watching the video. Hope you found this helpful. And this was my first attempt to make a video using this video capture and combining it with screen capture. I hope to do many more like these kinds of things when I have these questions now that this is set up. Thanks for watching, and if you like this, subscribe to the channel. You'll see these videos as they come up.